Hi everyone. So I have come up with the same circuit of architecture 8085 microprocessor that you can see over here. I have demonstrated all the part of this circuit earlier, and we have also learned that each and every register that you can see over here, accumulator, temporary register, flag register, and all the general purpose register in detail in our previous lecture. So I told you also that we will come back to the circuit and we will take an example of an instruction, and we will see that how does an instruction execute in 8085 microprocessor. So let's perform an operation. So we wants to add two number. Let's take these two number. One is 04 here, another is 03 here. Both two are the hex number, and we want to perform an addition between these two number. So to perform the addition between these two number, microprocessor has a particular instruction available to the 8085 microprocessor. So we need to write those instructions to the microprocessor, the instructions to perform the add operation, which is add register. So this is the basic instruction to perform the add operation between two number. Add register. This register could be any register among these 6 general purpose register B, C, D, E, H, L. That means, so we are assuming that I have written this instruction as add B. Instead of register, I have selected a particular register which is B, add B. So what does it define? It define that the addition of the content of register B to the content of register A, or you may say accumulator, and also store that particular result after the addition into the accumulator. So this define, let it repeat again, this define perform the addition of the content of register B to the content of accumulator and store the resultant value to the accumulator. So as you can see here, I have taken two numbers 04 and 03. So let it also be assume one thing. This 04 H, that means accumulator has been holding this 04H, this data byte, 8-bit data byte for a long time, as well as B, register B, which is also holding this 03 data byte for a long time. So now we want to perform the add operation. So before going to the instruction, it is an instruction. So when we will write some program to the microprocessor, we will not write the instruction directly to the microprocessor. Each and every instruction that I have told you before, each and every instruction has its own instruction code. So when we will write some program to the microprocessor, we will write the instruction code instead of the instruction. So each and every instruction has 8-bit instruction code. So for the add B, this instruction, let's assume this instruction code is XX. It could be, it has a specific one, but I am not that taking the specific one. I am taking it XX. So when we will write a program to the microprocessor, we will write this instruction code into a particular memory location, into a particular memory address. So I have also considered the particular memory location is 8000 that you can see, and I have given that instruction code into of XX into that particular memory location. So this was our instruction, this was our program basically. So when microprocessor will get that kind of program, what it will do, the program counter that you can see over here, this program counter, we all know this program counter holds the initial address of any program. So here I have my program was, what was my program? My program was 8000. This was address, and we have entered a particular instruction code into that address, which was XX. So this was it, and program counter immediately will be hold with this particular address, memory address that you can see 800. That means program counter will be holding with this address, which is 800. Now what it will do, it will place this address to the address bus. Where is address bus? Address bus is here, A0 to A15 address bus, and at that moment both higher order line or lower order address line will act as a address line, and this address will start to indicate the particular location into the main memory that you can see over here. So then the microprocessor will allow to read some data from the main memory. Then microprocessor will fetch or will read some instruction code, will read the particular instruction code, not the sum, will read the particular instruction code which is exist in 800 address location. So it will read that instruction code and place this instruction to the data bus. This is a data bus. This bus is data bus. The data bus will place that instruction code through this internal data bus to the instruction register, not here, to the instruction register. Now the instruction code XX is here, and then instruction register will send that instruction code to instruction decoder. Instruction decoder will decode that code here and will send that decoding message to the timing and control unit. Timing and control unit will know that which operation it needs to perform. When the code will be decoded and the message will send to the timing and control unit, then timing and control unit will come to know that it is a add operation. When it will come to know that it is the add operation between two registers, first one is a register B and first one is a register B and second is a register A, which is an accumulator that you can see over here, it will send an signal to the different type of register through its internal buses. It will send a signal to the register through its internal buses and will instruct this timing and control unit. All things, all the decision and all the control is performing by the timing and control unit, and timing and control unit will instruct the register B that please upload or please place your content, 8-bit content, which is 03H, into the internal data bus. So it will place this 03 content through these buses into the internal data bus, and then internal data bus will send that content 03 into the temporary register, which is 03 will be here. Now it will also instruct to the accumulator. So I have also told you that when the addition operation will be performed between two numbers, the first operand always come from the accumulator to the arithmetic logic circuit. Then the second operand will come, which is a 03, and second operand will come from the temporary register. So first operand which is 04 is holding by the accumulator. So first operand will come from this accumulator and it will be placed into that buses and will come to here, which will be suppose 04, and the second operand, which is 03, as you can see over here, it will come here, second operand, and will be placed into that logic circuit 03. Both is a hexa number. The operation will be 0, operation result will be 07 hex. So this hex number, this operation result will be placed to the internal bus. Internal bus will place that message to the internal data bus. Internal data bus will place that message to the accumulator. Now 04 will be erased, and the new value, it will be stored with a new value which is 07H. So this was the whole execution process of an instruction add B, add register, you may say, add between two number. So in that way the microprocessor perform all the operation, all the execution regarding their instruction in 8085 microprocessor. So that was a whole thing about the execution of an instruction.